So you're coming here not knowing anything about signal scripting, yet you're creating a route, or you're part of a team that is creating a route, and you have to do railroad signals, obviously, unless it's like some really old route or somewhere out in the boonies that has no signals. So signals are really, really important part of your route. There are two main components in Train Sim World to signals. And here, let me teleport to, I don't know, I'll just go to Forest Hills. And then just so we have something to look at. And then I'll start explaining the two core components. So the two core components are the signal view, and I'm looking at the very bottom right now of the content browser. That's what this area down here is called, the content browser at the bottom. So you have the signal view, which is the physical representation of the signal in the level, in your world. So this whole thing right here, the signal head, the lights, all of that stuff is built out in the signal view. This is the signal view. And if you click on it and you look at the world outliner at the top right, you'll see right here, this one's named LIRR Signal View 7, and it's of type LIRR Signal View. And it has a bunch of child objects, each of the heads, and the sign. So that's the view. When you add a signal into the route, which we'll cover later, you're actually clicking and dragging the view into the level. The other component is the model, which in the content browser is right above it. The model is the programming behind this. So a signal view without a model will just display like this all the time. It won't respond to anything. It just is there. The model is the programming behind how it behaves. Okay. Additionally, you have the heads. You can see in here the file structure for a route. There's a rail network folder, and then within that is a signals folder. All of the stuff for your signals is pretty much going to live in the signals folder, unless it's some kind of core component, which we won't get into. Actually, we can go into each of these really quick. So there's an aspects folder, which this one's pretty complicated because Long Island Railroad is probably the most complicated signaling system in Train Sim World, in my opinion. The aspects folder has each of the possible ways that the lights can be displayed. That's the definition of an aspect. And each way the lights can be arranged provides an indication, a meaning to the train operator for how to control the train. So the aspects are divided into clear, approach, stop, and then the ones that are specific for track circuits or cut sections. The reason I've divided them into these different buckets is because when you're playing the game and you look at the two-dimensional map, the color for the signal is based on the aspect. So clear are going to be your ones that show up as green. Approach would be your ones that show up as yellow. And then stop would be the ones that show up as red generally. And then the track circuit ones are specific to just the track circuits. So each aspect, and there's a whole bunch of how do I describe this? There's a whole bunch of blueprints that live in the core game that you reference for your project. The one for signal aspects is signal aspect base. So when you're creating a signal aspect, which is a way that your signal can be displayed, you are creating a blueprint with a parent of signal aspect base. We'll get more into aspects a bit later, but I just want to go through the whole file structure first. Because you're working in Unreal Engine, you have pretty much limitless power as to how you want your signals to behave. So all these other files here, if you were making just a basic signal system, you likely would probably just need a couple of these as opposed to all of these different things. All right. Cabinets. I don't know why this got lumped in here. These are literally just the wayside signal huts. I don't think there's any here, but these are just meshes that they added into the world, and they just lumped it in the signals folder. Heads. This one is very, very, very important. The head folder contains all of the meshes for your heads. So if I open this up, all of your individual static meshes, all the materials that get painted onto them, the textures, the individual blueprints for your head assemblies are in here. The lenses, so the actual lights, are in here too, along with their respective materials. And some other information. So each head references this master head for your signal. So every head is a child of LIRR head base, which has some basic functionality that applies to all signals, which we'll get into a bit more later. So yeah, heads is probably your most important subfolder along with aspects. Materials, this is just going to be other materials that get painted onto your objects. Ignore it for the most part. Posts, these are objects and other things you can use to attach your signals to things. And they're just cosmetic. So like that little pole right there on that signal would live in posts. Setup, I decided to use this folder for all the custom logic stuff. So all like the super custom programming things that I did for Long Island Railroad, I decided to throw in there. And then textures are just that. They're just textures. Then you have your signal model, your signal view for both your wayside signals and track circuits in this case. And that comprises your whole signals folder. Okay. So what I want to do next is dig a little bit more into the signal view, the part that you actually add into the world. We'll start by actually adding one into the world. So I'm just messing around in the Long Island Railroad route. When I drag this into the world and attach it to the track, you're going to see a lot of stuff happen. And I'll explain what is happening. So I'm going to click and drag a new signal view in, release, and then you're going to see this arrow. And this arrow shows where the signal will actually be connected to your track. So you can see this one is pointing back that way. If I left clicked right now, it would govern movements in that direction because that's the direction the arrow is pointing. If I instead wanted it to govern movements in this direction that we're facing now, you have to press shift in order to switch the direction that the arrow is facing. So I'm pressing left shift right now on my keyboard. If I press and hold it, it points that way. And then you can left click to attach it to your track. So I attached it to the track, and you see all this stuff right here. Routing table cleared due to network modification. All right, I'll just move this over here for now. So what we've done so far is attach a signal to our track network. there's some other setup stuff that need to be done first in order for it to become functional. So when I clicked and dragged the signal view into the world and added it to the track, you'll see all this stuff over here: head preset, head templates, post templates, etc. This whole configuration section here is for customizing the signal to look like one of these. Everything that goes into the physical, visual appearance of a signal. So just to play around, we can quickly just make it look like, I don't know, a one-head wayside signal. So if I expand component 0 here, you'll see a whole bunch of stuff. Actually, we'll make it a two-head signal, because that'll be a good lesson. If you do this drop down here, everything that has every head that is a child head of this a child blueprint of this LIRR head base will show up. So how did we get it to show just those types of heads? Well, inside the signal view blueprint, where is it? Trying to remember where it is. Head preset, head templates. All right, yeah. So inside the signal view, down here in variables, there is an array of head templates, post templates, sign templates. When you click on those variables, you can see that the variable type is LIRR head config. All right. So when we go back here, you can see that this head templates is an array. It's a combination of different variables. So you can see right now, by default, it has one array element. If we wanted to add another head, we'd hit the plus, and now it has two array elements. So let's take a look at this LIRR head config. It lives within signals heads, and you can see right here a structure called LIRR head config. If we open this up, a structure, by the way, is just a combination of different variables together that you can just drag into a blueprint, and you have all that information there. So this particular structure has a type of head, which is of LIRR head base. That's how that dropdown is only showing LIRR head base blueprints. The number in the stack, that's for like ordering the signal heads if you have multiple signal heads, and then some other stuff. So all that is added into the signal view, and that's how we can see it over here. So we'll choose, we'll do that one. That's fine. We're going to make this a two-head signal. Just taking a quick look at the chat. I don't see anything. We're going to make this a two-head signal. So this stack index, stack total thing will change. As is typical with programming, these start with 0 and work their way up. So if you had a 3-head signal, it would go 0, 1, 2. We have a 2-head signal we're going to make here, so it's 0, then 1 are the head numbers. So the first head will be 0 out of 1. And we expand the offset section, we can adjust the location of it relative to the origin of the blueprint. So for now, we'll just put this one, I don't know, 300 higher. We can adjust it in a little bit. All right. I'm going to hit plus, so add a second head. We're going to choose, I don't know, let's choose, no, not that one. Not that one. Yeah, we'll do that one. That's fine. So this is the second head, so it's stack index 1 out of 1. And we'll raise it up a bit. I don't know, 150. Yeah, that looks fine. And then by default, you'll see this concrete base in there. That's from this root static mesh thing. If you wanted to get rid of it, you can just click in here and just hit clear, and it gets rid of it. But yeah, that's the basic, like the most basic setup of a signal view. All right. To configure it further, you actually have to click into this network signal component edit property thing, and that actually brings you into some variables that live in the signal model. Before we do that, though, I want to go back into the signal view. You'll see in the components area in the top left, the signal component. That's actually the reference to the signal model. So within the signal component of your signal view, this signal model property class is going to be the blueprint for your signal model. So that's how you're associating the signal that you're dragging into your world with a specific set of programming, if that makes sense. Okay. While we're still in the signal view, you may have noticed that when I clicked on the head class, the type of head dynamically changed. Well, how does it do that? That's all stuff that lives in the signal view. And there's a thing in Unreal Engine called a construction script. So if you want to use scripting to build out things in the editor, you do that in the construction script. The construction script isn't executed. How do I say this? Actually, I don't want to say that. But if you want to build stuff out within the editor and have it carry over to your game, do it in the construction script. So there's a create heads section here. Let me make this a little bit larger. All of this is kind of like cookie cutter default type stuff that all roots will have. Basically, it's just taking whatever you're putting into the into those fields, breaking it. So with structures are pretty cool. You can take a structure and here, let me pull up the structure just so you can see it. The head config. So the structure is a combination of these 7 variables. I didn't pull down far enough. When in a blueprint you break a structure, you're taking the whole structure and breaking it into its individual components that you can then reference and manipulate, which is awesome. And I use it all the time. So this particular one is for each entry in that head templates array. So for both of these, it'll go through the first one and then the second one. It's taking all of the variables, it's grabbing the head class, which is the type of head that we chose right here. And it is then, let me see right here. It's adding that as a static mesh component to the object that's already placed on the world. Essentially is what it's doing. So it's pretty cool. And you have to do this in the construction script, so it dynamically happens as you're making changes in the editor. Okay. That's pretty much all I wanted to show with the signal view. There's other construction scripts here for the posts. So if we were attaching posts to the signal, signs, updating the signage, if you wanted to add any special debugs. So as I'm developing, sometimes I'll add debugs to the signals, and it would literally just be like some text that says, oh, this is the signal name, this is the signal aspect, these are some additional data that I might want to see for debugging purposes. I don't see anything in the chat yet, but feel free to ask questions, guys. That's what this is for. I could have just made a video and uploaded it, but I wanted to do it in a live format. Shit. Let me just refresh this, make sure that I'm not missing anything. No, I'm not missing anything. Okay. Yeah. So the signal view debugs, that's what I was talking about. So you can add text, like for this one, what was this? This one was literally just adding text and just grabbing the signal aspect, and whenever the signal aspect changed, it would modify the text, and this would only apply to when I'm in the editor. All right. What else does the signal view do? Not much. When you start playing, it runs an update, which literally just updates the signage. Gets, what does it do here? Oh, it ends up just getting what signal aspect it should be displaying and then just displays it. So that's all really the signal view is doing. All of the big heavy lifting programming is done in the model, which we'll look at now. The signal model, this is the signal model for, actually let me close all these tabs. We'll start with the basics. So the signal model is a child of the parent class network signal property. So when you're creating a signal model, you're going to, here, I'll just go down to the content browser. We will go to new blueprint class, and you'll search for which class you want to reference. It would be network signal property. And then you'd hit select, and it would create a child blueprint referencing that parent blueprint. You can see here the signal view is the network referencing network signal actor. The model references network signal property. And these are core blueprints that come with the game that are available for you to reference and build upon. All right. So that just provides the basic functionality for your model. How do you actually create signal programming? Like, what is required? And that's kind of an open-ended question because, like I said, you're using Unreal Engine. You have so much power with this scripting, this Blueprints visual scripting, that you can do pretty much anything that you want. However, I'm going to go through the way I do it and the way I understand it. And you can either go with that and then build off of it, or just do what I do. So in the main event graph, so there's an event graph here. This is where all the action happens, or starts anyway. Certain events get fired off as you're playing the game. This could be things, actually, let's just go through them. Event on signal ahead aspect propagate. On route assigned. On junction changed. On occupation changed. On signal ahead aspect change. On signal ahead indication change. Initialize. All right, so initialize is a pretty common one that applies universally to blueprints. That's when the level begins, when you're loading the route. Anything past initialize gets fired off. These other events get fired off in response to other things happening throughout the route. So if the occupation count of the signal changes, meaning if a train enters or passes the signal or leaves the range of the signal, that event gets fired off and certain things happen. When the dispatcher assigns a route for a service through the signal, this one gets fired off. When a junction changes that this signal protects, that event gets fired off. When a signal ahead is sending information about its aspect back to other signals so they're aware of it, this one gets fired off. The point is, and you can see they all culminate into firing off this update function. Basically, whenever these events happen, when the signal aspect ahead changes, when the junction ahead changes, when the dispatcher assigns a route, when the occupation changes, when we start playing the route, we want the signal to perform an update, because these are all conditions that may warrant the signal aspect to change, you know? So let's dig a bit deeper. We're just going to keep unpeeling the onion. So let's go into the update function. The update function will get the aspect that the signal should be displaying, set that in here. This is a core function that actually sets the aspect at a core level, and then some other stuff happens. But basically, all that's happening when a signal updates: get the aspect, set the aspect. Ignore all this other stuff. This is specific to Long Island Railroad. These were some special things that I had to program in. All right. Get the aspect that we need to display, set it. That's what's happening. All right, so let's figure out how to get the aspect. Well, this is up to you. All right. This is entirely up to you, but there are some common prerequisite things that I would say apply to all signal models. And we'll go into that now. I tried splitting this up nicely to make it look as like a flowchart as possible, so it's not all over the place. I've seen some disgusting looking blueprints in the past, and I did not want to recreate that. Okay. So we enter the function here. You'll see this thing called a sequence. This was just some way for me to clean up my code. So it goes to the first item. It keeps going. As long as there's an execution pin, it'll keep going through until it reaches a point where the execution pin doesn't connect to anything, and it ends that part of the sequence, and then it will start the next part of the sequence. So instead of having all these lines everywhere connecting everything, I just use a sequence node in order to keep things nice and tidy. I just want to point out the stuff that would be relevant to all signal model stuff. This would not be relevant to anything outside of Long Island, really, or any route that uses a timing system for signals. I'm not going to dive into this too deeply, but Long Island Railroad uses timers a lot to influence the cab signals in the train. So I had to do a lot of stuff to make that work nice and cleanly. So, and that's why I'm resetting a whole bunch of different variables at the very beginning. But this is a core piece that every signal model should have. Do we have a route assigned by the dispatcher? That's the first question that you should be asking. So by default, when you start up a route, actually, let me do that really quick. Let's save this. Actually, yeah, we'll keep that there. Let me save all this. Let me open up my test scenario. We're gonna... Yeah, we'll start there. And we'll just go to the end of the platform at Hicksville. I'll explain later how to test your signals by doing this. Alright, so I'll just wait a moment for this to load. Scenarios take a moment to load in the editor. Especially on a route as big as this. There's a lot going on. On a smaller route, it will load much, much quicker. But this is a fully built out route. Alright. So I'll explain a little bit what's going on here. So this train I spawned just outside of Hicksville. It's going to be switching tracks over to track 2 and pulling into the platform at Hicksville. So that first step in the signal model is checking if the dispatcher has assigned a route to you. Well, one moment. There's a train going by my house. For those who don't know, I live next to an active railroad, so I just didn't want you guys to hear all that noise. My train right here is set to be routed through this signal, switch tracks and everything, and go to Hicksville. The dispatcher has assigned a route for me through this signal. Alright? There is no service set to go through this signal, so the dispatcher has not assigned a route. Alright, that's the distinction. So if I go back to the signal model, actually, let me hop out, just so it's a bit easier to see. Alright. If I go back to the signal model, I can get rid of that. Check if the signal has a route assigned. Alright. If no route is assigned, the signal gets set to stop. That's just how I've done it. So there's a node that comes built in with network signal properties called get signal assigned route index. There's also one that I just deleted called has assigned route, which returns a Boolean. That might be a cleaner way of doing this, as opposed to checking whether the assigned route is greater than or equal to 0. So when you don't have an assigned route, this node gets returned as -1. So that's why I'm checking to see if it's greater than or equal to 0, because if so, then it's been assigned a route. The routes are numbered. So when you build out your signals, here I'll just click on this signal. You go down to the signal network signal component, hit edit property. If you go down to routing, you'll see a routing table that gets generated, which we'll go over later. These are the route indices that we're talking about. So if it's been assigned route 0, which it means that it would be routed through this path, it would return 0. If it was assigned a route through this path, it'd return 1. So basically 0 or higher is good. If it's true, meaning a route has been assigned, it goes to the next part of the sequence. If no route has been assigned, it goes to this section. And you can see I even wrote out the comment here. Route not assigned by dispatcher. Set signal to its most restrictive aspect. And I even set like a little note here. Route not assigned. This is just LIRR stuff. But the essence of it is set decided signal aspect to stop and return that. So If you don't have a route assigned by the dispatcher, you're in and out of this function that quick. It's, yeah. But let's say we do have a route assigned by the dispatcher. There's some other stuff we got to check. And this is another one that's going to be universal to all routes. There's a function, it's a function that's built in that you can use called get signal junction route state. So between this signal, this is a bad example because there's no junctions, but same principle. Between this signal and the next signal, if there are any junctions, it checks the state of each of those junctions. And when you fill the route track sections, which we'll go through later, all of that stuff gets determined. All right. If all the junctions are set and locked and are good, meaning they're all lined in your favor and nothing is lined against you, it returns set and locked. If the junctions are not set, meaning like one or more of the junctions are lined against you, so you can't actually move through to the next signal, it'll return not set. There's also another flag for if you're dealing with manual junctions ahead. So like if you're entering a non-dispatched yard type area, in the majority of cases, it's going to return set and locked if everything's A-okay. If everything's good, set and locked is what you want to see. All right. So let's say we have a route assigned by the dispatcher. The junctions are lined properly. What do we check for next? Occupancy. This is also going to be a universal thing that you add into your signal model. It will get, this function, get signal assigned route occupancy state, will get the occupation of this signal, whether it's occupied or not, if it is occupied, by how many trains. Basically, all you're really caring about is clear versus occupied. If it's clear, it's fine, and we'll continue to the next part of the sequence. If it's not clear, meaning if there is a train occupying that signal, this is where you decide how to handle that. For Long Island Railroad, it was setting the signal to its most restrictive aspect. Stop and proceed, that sort of thing. All right. So now that all the prerequisite checks have been done, we have a route assigned by the dispatcher. The junctions are set and locked, and there are no trains occupying our block. We now have decisions to make. What is our signal going to actually display? And this is where you come in. This is where you design your signal system to figure out what the signal should display. I'm going to go through it for Long Island Railroad. I'm just going to try and skip some of the more complex or irrelevant bits. So the most common way people are going to figure out what this signal should display is based on what the next signal is displaying. Some common examples with Northeast Corridor stuff. If the next signal is displaying stop, we'll display approach. If the next signal is displaying approach, we'll display advance approach. You know, those decisions can be as basic as that if you're not set to switch tracks or anything. So all I'm doing here in this block, these green blocks or teal blocks at the top are just getting information. So what I'm doing here is I'm getting my assigned route by the dispatcher, the route number. So like I described with this example before, if you look at the routing table, I disabled route 0. So if you do get a route from the dispatcher, it's only going to be route 1. So let's say we got route 1 from the dispatcher. All right, assigned to us. That's what that would return. 1. It returns as a structure, and like I mentioned before, with structures you can break them and get the information contained within. So what this is doing is it's getting our assigned root through this signal to the next signal. It's getting the reference to the next signal, which if you expand the root, you can see there is, in this structure, a next signal reference. And it's actually like the type of signal model. It's actually, no, that's the object name in the world. And then here's its GUID. So it's a hard reference to the next signal, which in this case, if we go down here, is this guy right here. All right, that's the next signal that's being returned as a reference. So let's continue. It's getting the reference to the next signal. You can feed that into another built-in function called getDistantSignalAspect, and then it returns the aspect. Pretty cool. So what we've done here is we got a reference to our next signal and got its aspect. And I'm storing that in a variable for later use. All right, for us to figure out. It's just more information for us to do stuff with later. All right, so now we've gotten that. If for whatever reason we can't return the signal aspect, or it's not a valid signal aspect, then you can choose to do some other stuff. All right. What I'm doing here is finding the next wayside signal. This was a LIRR specific thing, but it has come in handy. Actually, no, it's come in handy for other routes. It's coming in handy for Boston to Worcester. So, how do I word this? So let's say we'll be deciding the aspect of this signal based on what the next wayside signal is displaying. All right. Well, the next signal isn't a wayside signal. It's a track circuit. The one after that is also a track circuit. And the one after that is also a track circuit. So you have 3 signals ahead of you that you have to go through before you get to the next wayside signal. But let's just say that we want to determine the aspect of this signal based on the aspect of the next wayside signal. Well, how do we find the next wayside signal when the next signal is a track circuit? There's a thing that you can do, and I'll go into this graph. There's a function, again, built in, that Dovetail Games made, called iterate assigned signal routes. So what this will do, and you can use this too, is it iterates through signals ahead of you. All right? And it stops when it's either reached a distance limit, a set number of signals, or when certain checks pass or fail. So there's I don't fully understand all this, but there are these things called predicates. These are essentially conditions that have to be met in order for this iteration to stop and for it to actually return a signal. So like I said before, we want to find which signal is the next wayside signal. The next 3 signals are track circuits. Those aren't wayside. We want the 4th one. So how do we get the 4th one? I created this function, signal is wayside predicate. I can go in there. And it's just going to return like a yes or a no as to what constitutes wayside versus not wayside. So you can take a look at this. I'm not going to explain it. It essentially just returns a yes or a no. And the iteration function will look ahead at the next signal and say, do you pass this valid predicate check? No. So it keeps going and going and going until it finds a signal that meets the requirements, which would be the next wayside signal. And it spits it out as this signal reference. And then we capture a reference to that signal and store it in a variable called next wayside signal. And I end up using that for other parts of my signal model later on. I kind of dove into that a bit more than I wanted to. Sorry. But that's how you can... It's just another tool in your arsenal, using the iterate function. All right. So we've gotten a reference to the next wayside signal. We can get its aspect and store it for later use. Next wayside signal aspect. I'm also finding the next signal regardless of type. We're just doing information gathering right now. There goes another train. So the information I've gathered so far is the aspect of the next signal, a reference to the next wayside signal, a reference to the next signal in general, and all this other stuff is just gathering more information. I don't want to get into intermediate signals right now. We'll get into that more later. Just more information gathering. These are all custom things that I've made with the signal. Oops, 1 second. My neighbor's making a lot of noise. I'm just going to close my door. All right. So I've made a lot of custom variables in the signal model that relate to what kind of decisions we're going to be making about our aspect. You can do the same too. All right. But this is basically just gathering all that information for the next signal. So now that we've gotten a reference to the next signal, we can now grab information from that specific signal, which is pretty cool. So yeah, definitely get your references early on, because then you can start grabbing information about those signals. All right, we're going to skip ahead a bit because all of this so far has pretty much been information gathering. Now you need to use that information in order to make a decision. There was a system that I made starting with Long Island Railroad Extended, where I can, as the signal programmer, decide on a per signal basis what the signal is going to display, given a set of conditions. And that's what this top section is all handling. This is all your custom logic stuff. I'll show you that briefly. I'm not going to get into really how I did it, but there's a whole custom logic section here within the signal model. And I've added 5 different forced possibilities. So I'll just expand the first one. If the next signal is a wayside signal, you see how that's important, whether getting the references to the wayside signals and the track circuits. So I'm saying if the next signal is a wayside signal and it's displaying clear 80, then we will display clear 80, and then we'll set all these other parameters. So I made this whole custom logic system, and all of that is being handled up here. So all this is saying is, if there's custom logic, look through it. If there's a match, great. If there is no match in the custom logic table, then we have to fall back to some other mechanism of deciding our signal aspect, the default logic. So the default logic is all here. let's look into some of it really quick. A basic one. This block yeah, there we go. If you have 2 consecutive block signals, all right. Basically, these are just a bunch of checks. That happens, and then you end up outputting the decided signal aspect. All right. We'll just do a quick one. So if the next signal is restricting, all right, and it's located in LIRR territory, then the signal will display approach, and then sets some other stuff. It sets that decided signal aspect and returns it. That's the essence of it. You're getting information, and then you're using that information to set this variable, decided signal aspect. All right. How you decide to do that is up to you. And then at the very end of the sequence, you return the decided signal aspect. Oh, there goes another train. That's what happens when I do this on a weekday. And then when you return that signal aspect, it gets fed over here and it gets set. That's it. So just to recap, you are checking whether the signal has been assigned a route by the dispatcher. You're checking to see if the junctions are set and locked. You're checking to see if there are any trains in your signal block. And then getting references to the signals ahead, grabbing information about those signals, and then using that information to make a decision. And that decision ends up setting this variable, decided signal aspect, which gets fed into here in the update function. That's the essence of the signal model. As you can see, they get extremely complicated if you want them to be. This is probably the most complicated signal model. It's definitely the most complicated one I've ever made. Like, for Boston to Worcester, I took this, copied it over, and stripped shit out of it. Stuff that I don't need. Like, that's how complex this one is. Okay. I don't see any questions about signal model or anything. Let me just refresh this. Oops. 1 second, my chat's not working. There we go. All right. Now I don't see anything. So we will continue with where we left off at Forest Hills. Let me save the signal model. Okay. So before we placed this signal on the ground, we attached it to the track. Then we added the head templates to it, chose which heads to apply, set the numbers properly. So head 0 is 0 out of 1. Head 1 is 1 out of 1. Starts from 0, works its way up. Now we need to... Actually, let's not even mess with any of the... the custom stuff right now, because none of this is going to matter to you right away. We'll leave all these at their defaults. After you add a signal, you need to do what's called a signal fill. All right. So there's a manage track sections icon. It's the 4th from the bottom when you're in network edit mode. And when you click it, it's going to show you your track sections. Black means you haven't generated your track sections yet. Any other colors or patterns means that they have been filled. So when we added this signal into the mix here, we broke all of these sections and up to this signal. So the signals basically right now don't have any next signal references. You need to build all that first. So you literally just click in here and manage track sections and you click fill. All right. And you're going to see that the colors shifted around. It's red here, and then there's like a break at the signaling points, and then it goes back to red. It's just random. You'll see here at this point, it switches to another color. It's a different track section. Okay. At this point, when you do a signal fill, that's when the routing tables for the signals get generated. Okay. So if I click into this signal, which is the previous one to the one that we just placed, and I scroll down to edit property, and then routing, you'll see here I have one route, one element in the array of routes, and it's to this signal here. We didn't give it a name, so it just shows up as its GUID, its globally unique identifier. If we come down here and give it a name, if I scroll back up and I click on edit property and go to signal ID, we'll just type test signal. All right, we'll go back, we'll look at the routing table again, and you'll see that the GUID has been replaced with the friendly name. Okay. Cool. What else do I want to show you about that? Oh, there's a bug in the game where a lot of people will pull their hair out. You add your signals, you do your signal fill like this, and then you go to save everything, and none of your signals work. Like, everything is broken, AI won't move. There's some commands that need to be run in order to fix this kind of thing. So there's several actually debug commands you can run. I'm trying to remember what this one's called. ts2.dbg. Yeah. So ts2.dbg.test signal tables match get next track section. So this is just, I don't know exactly what it does, but it makes sure that everything, all the track sections and the next signals in the routing table are good. What I've found, especially on big routes, when you add a signal or mess with anything on the track that breaks the track sections, see, you'll get all these errors, and this will destroy a route. You can't do that. So let me clear the log. There's a command. It's called ts2.dbg. I'm trying to remember. It had the word dangerous in the name. Oh yeah, ts2ed.tools.dangerous update signal route sections. Don't get scared. It says the word dangerous. It's not. I've never had an issue with it. So then you run it, and then run the test again, and it shouldn't return any errors. Problem is, when you do that update, you're modifying a lot of files, as you can see here. You just make those writable and save them. So that's how you do a proper signal fill. Just remember that when you make changes, it breaks the sections. You'll see it represented as a solid black line. You go into network edit mode, manage track sections, hit fill, and then you have to run those two commands to check for track section continuity and everything. All right, let's get a little bit more into how to configure this signal. Actually, let's just leave it at defaults for the moment, and let's create a quick little scenario to route a train through it. and see what it does. All right. Just zooming in here. Okay. Oh, another thing. When you look on the 2D map, in the editor, that is, you'll see that your signaling points are green, yellow, or red. This isn't the aspect. This is the configuration state of the signal. So when you add a signal for the first time and the track sections haven't been generated, it'll show up as red. If you fill the track sections but you haven't validated the signal routing table, so there's a checkbox here, content have filled and checked within the routing table. If that's not checked, it'll show up as yellow, and if it has been checked, it'll show up as green. So just so you know. Let me just make sure my train's being routed properly. Yep. Looks good. So we didn't apply any custom logic or anything to the signal. We literally just placed it and put the heads on it. Let me configure the head types because that is kind of important. VHR and RL. I think that's right. None. Oh, signal classification. That is kind of important for my signal model. We're just going to put block signal. All right, that's all I'm going to change for this one, for the moment. And we'll set it to stop and proceed because it is a block signal. It can't display absolute stop. Okay. So I will make sure that that scenario is compiled. It's just going from Forest Hills to Penn Station. Wait for that to load for a moment. I don't see any questions in the chat. Throw them in there. Now's the time. But this video will be archived on YouTube, so you can always just ask a comment there after the fact. Or just reach out to me on Discord. We'll go for a little while longer. I'm not sure how much more I have to talk about. There's a couple things I want to mention. Mostly like quirks and lessons learned over the years. Just waiting for this to load. Come on. All right, there we go. So you can see the signal in front of me is displaying clear. This was one of the existing signals. And, sorry, play in editor is a bit stuttery. And you can see the next signal that we placed is clear. All right. So how did it get to that state? How did it decide? I just want to step through it with you really quick. So it eventually gets to this get desired aspect function, has a route assigned by the dispatcher, junctions are set and locked, no trains are occupying it, gets a whole bunch of information, all right? There's no custom logic, so it goes down to this area, and it starts to figure out a decision to make. I'm just going to tell you the next signal classification is I believe, code change point track circuit. And the next signal is... Wait, no, sorry. This is a block signal. The next signal is a code change point. All right, so it goes to this graph. The next signal I know is displaying 80 on the track circuit. So it goes all the way up to the top. Next signal 80 or 70. If we're in LIRR territory, which we are, set our signal to clear, set some other stuff about the signal, set the decided signal aspect. That's how it made its decision to be a clear signal. Okay? We do have a question from Dutch. Are there any videos about modeling trains and getting them in game? Not ones that I've seen. Okay, so that's the absolute basics for getting a signal up and running. Now I just want to go over some quirks and other stuff that I've seen. When you're configuring a signal, one of the default fields is signal type. So when you go... Here, I'll show you how I got here again. When you go into network edit mode and you click on attach linkable objects to the track and you left click the signal. Oh, it's acting funny. There we go. Network signal component, edit property. This is where you do your main configuration for the signal. The signal type is part of the basic setup, and there's a whole bunch of options. Mainline being the default one. So the mainline signals are ones that are controlled by the dispatcher on the main line. There's no kind of yard happening here. It's just typical mainline traffic. Yard entry, do not use. Dovetail has warned us not to use it. It is bugged. Basically, its intent was to be... This was the last signal before entering non-dispatched, non-signaled territory. So you're going into a yard, essentially. Meaning this signal would not generate a routing table. Here, if I, at least I believe that's what it would do. Uh-oh. The editor's freaking out on me. The editor might crash on me. Give me a sec. Alright, it didn't, but I thought it was going to. Let me clear the routing table by right-clicking the signal, and you can just hit regenerate signal table. Actually, let me get rid of it and just delete the array. Then go to regenerate signal table. Oh no, it does generate a signal table if the signal type is yard entry. But they don't want us using it because it's busted, apparently. It messes with the dispatcher. So just don't stay away from yard entry. Yard exit is very, very, very important. Let me save and go to a area that would be used. Where's a good spot for that? Probably one of the yards down by Hicksville. Yeah, down. Is that a good example? Yeah, screw it. It's a little trick, by the way. If you open up the route map in the editor, you can right-click on an area and jump 3D world to here. Pretty cool. All right, so I have this signal point here, which is hidden underground, because in real life, there's no signal here. However, the dispatcher needs there to be a signal there. All right. And this is one of those yard exit signals. So if I click into here, you'll see that the signal type is yard exit. So after this point, you're starting dispatched area of the network. So if you're leaving a yard, going into a signaled territory, you will need to place yard exit signals. Okay? Very, very important. So I just took a generic dwarf signal and hit it on the route map. That's actually a toggle that's built in. You can hide things on the route map. Yeah, and it just kind of sits there, and in order to help out the dispatcher. All right, what else could I tell you? Default stuff, not custom stuff. Default. This is something that's come up a couple of times. There have sometimes been signals that even when there's no train being routed through them, we still wanted them to display a normal aspect, like instead of stop, approach, for instance. This happens a couple times in the Boston to Providence route. There's a thing here called default signal aspect. And for this one, I set to stop and proceed, but you could set it to anything. And then if you want the dispatcher to always have a route assigned to it, so it displays that aspect, you can change this default route box. So the default route is -1, meaning the signal doesn't have a route assigned by the dispatcher at first. If you want to force one to always have a route, you can do that. So I could set that to 0 and it would always show something permissible or whatever. What other tricks? Dispatch block count is pretty important. So how do I describe this? It's the number of signals ahead that the dispatcher will reserve for you. So let's say, this will be easier if I go back to Forest Hills, because there's just more signals stacked up there. Just wait for this to load. Okay, so dispatch distance. Where am I? Okay. So this signal, if I left click on it and go to edit property, the dispatch block count is 6. So what the hell does that mean? It means that 6 signals ahead of this one will be reserved by the dispatcher when you have a train here. So let's count that. Let's ignore this one. 1, 2, 3, 4, 5, and then 6. So I believe this last signal would be stop and proceed, and then the previous wayside would be approach, blah, blah, blah. You can set this number higher than, and if you do, it's going to put more stress on the dispatcher, and it could also lead to the train reserving more blocks than it needs to at any particular time, which could affect you simulating the timetable properly. So basically, signals should only need to dispatch as far ahead as they need to in order to display their whole range of aspects. If you set it too low, then you might not have a clear signal here. It might just be like approach or something. It just needs to be high enough to display the full range of aspects. the first route that I did a full optimization of this on was Boston to Worcester. So I actually went through each signaling point and manually tuned the value to what it should be, instead of just relying on a baseline number like 6 or 7, or in New York to Trenton's case, 9. There are cases where 9 would be appropriate and required, but not everywhere. So just know, if you're looking to optimize performance, reduce this number, but not at the expense of realism. All right, so that's dispatch block count. All these other settings don't really get used all that much. The SPAD control group I've never used. Overlap I've never used. Approach release I've never used. I've never used any of these triggers or anything down here, so you can ignore all that. Target stopping distance. So if this is for AI, so if this is a stop signal, and this will specify how far back the AI comes to a stop. So if you wanted to, you could mess with that. It's by default set to 10 meters. I think that's about it. The rest of the stuff here is like, oh no, aspects. So we talked about this a lot in the model. The whole point of you making the signal model is to decide what aspect the signal will display given a certain situation. There's a core component called the signal aspect base. You can see that parent class up here in the top right. So your signal's aspects, you're going to make one that is a child of signal aspect base. Now, what's in that? There's a whole bunch of default stuff. Actually, not a whole lot, actually. What are the class defaults? I don't know. Is that inherited? No, signal aspect base. So aspect class, aspect name, right, the name. It's mostly like the name, whether you can SPAD, which means signal passed at danger, when you pass it. The name that will be shown on the 2D map when you hover over the signaling point. Let me just open up a basic one to show you. If I just open up approach. Ignore all this stuff. That the top stuff is all like custom stuff. So for each one of your aspects, you would make an individual one of these and give it a name. You can even type in the operating rule if you want, which could show up on the map. Whether you can SPAD when you go past it. The only one that you will SPAD is stop. So I'll show you that. Yep, you can see that that's ticked. So that's another thing that you need to make sure that you do. Those are your aspects. See if there's anything in the chat. Nope, nothing. Maybe just one more thing. This might be a bit too much though. How do you actually get the signals to light up the way you want? Let me just open up one of these and we'll do the one that we added down here. So what's this head type? PRRPL01. PRRPL01. All right. So there's a master head blueprint that all of these reference called PRRPL base. Basically, what these do is take the aspect. So it takes whatever aspect is set by your signal model, and it decodes it. All of this is made by Dovetail. I just kind of reused it. Takes the aspect, and based on whether it's on a single head signal, the upper head, the lower head, blah, 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 it finds out, it classifies it based on the name of the aspect. So like clear is thrown in the clear bucket. Anything with a plus means flashing. So clear plus would be like green flashing. So yeah, it classifies it like that, and then sets the lights based on that. That's all really. I make it sound easier than it actually is. But yeah, if it's classified as clear, goes to clear, sets the lamps a certain way, and that's it. And that's done for each type of signal head. Kind of a pain in the butt. I could see people having problems with this. So hopefully some source files can get released so people can play around with them. But you can at least reference the video. Nothing in there. Set lamps function. Oh, when you're actually like, actually, let me go back to the other head. PRRPL01. If you go into the viewport here, and you can see the components in the top left, you can see all the individual components that went into making up this signal that you see in game. So it's not like they just imported a 3D model and called it that. Like you have the backer there, you have each individual light that gets placed and given a name. And you can see the name like green 01, yellow 01, red 02, green 02, white 03. In the head blueprint, when you go to set the lights, you're referencing those individual lights, yellow 01, yellow 02, and you're setting those lights on and off individually. So that's how that's done. But I think that's it, guys. We've gone over quite a bit. I'll just do a quick recap. So in a root plugin, there's a Rail Network folder and a Signals folder in which all of your stuff is going to live. In the root of that, you have your signal view and signal model. The signal view is the physical component that you drag into the world in order to display the 3D model, the lights, all that stuff is done through the view. The model is the programming that drives how the view behaves and interacts with the dispatcher. To attach a signal to the track, you drag, here, let me delete this one from the world. You drag a signal view in, and this arrow appears on the track, which shows the direction that the signal will travel in. If you press left shift, it changes the direction, just like in Train Sim Classic. All right. When you go into the track sections thing, after adding a signal, you'll see that the track sections are like black, which means they haven't been generated. You have to click on fill in order to generate them. However, that may cause some corruption. So there's a couple commands that you have to run. One of which is to test that the signal tables match the next track section. That one didn't fail. Sometimes it fails and it returns a whole bunch of errors. Oh wait, shit, I did that wrong. Sometimes it fails and it returns a whole bunch of errors, in which case there's a dangerous update signal routes section command that you have to run in order to fix that. We went into the model, how the whole purpose of the model is just to determine which signal aspect to display. What else? We went over configuring the heads, how to add multiple heads, how to number them properly. Like if we had a 2-head signal, you'd have to change these numbers around. All right, that's all I really have to discuss. I'm hoping that Dovetail can provide some source files like this for reference later on. Maybe I'll be able to provide some of the Long Island stuff. I don't know. It's their intellectual property. I can't just give it away. But they didn't have a problem with me showing it to you, which is cool. If you guys want a follow-up stream and you got more questions, please just type in the comments your question. I'll try my best to answer the question in the comments, but if we get enough of the same question or a whole bunch of different questions, it may warrant an entirely different video.